Hello dear students, good evening to all of you. So we have been discussing the chapter complex numbers and the competitive part of that. We had just introduced what is called as polar form in the last class. So therefore now I am going to start with polar form in this class. So the knowledge of Cartesian form is not enough to do problems in competitive exams. Some simplifications go excellently well when you use polar form. Therefore, today we are going to deal with what is called as polar and exponential form of complex numbers. In fact, most of that will be of polar form only. So we have to discuss what is called as polar and exponential form of complex numbers. Yeah, so I will just introduce the small model for this. Then our more highlights will be in solving problems. Yes, so therefore the first thing is what I want to say is, if you take a complex number, so we know a complex number is a number of the form z is equal to x plus iy, and we know that this complex number can be treated as an ordered pair. So we can take this complex number as x comma y. Yes, and once you take it as an ordered pair, it can be plotted on a plane. Yes, so I will take this as x axis, which is also called real axis, and this is called the y axis, which is also called imaginary axis. So y axis is called imaginary axis. Now if you take this point x comma y, let us assume that this point is in the first quadrant for simplicity. So suppose you take this point x comma y in the first quadrant. Now my assertion is that this complex number z, which is equal to x plus iy, can be written in the form r into cos theta plus I sin theta, and this form is called the polar form. Yes, now how is this? Just a very simple explanation to this. So the thing is, we are going to join this point to the origin by using a straight line. So this point, we'll call it as O, and okay, let's take this point as P, and from this point we are going to drop a perpendicular to x-axis, and let's assume that this angle between the x-axis and this line, let us assume this angle is theta. And we clearly know that if I call this point, let us say, as some m or something, we know that the distance OM is actually x, because the horizontal distance is always the x coordinate, and the length PM is actually y. And this length OP, will give it a random name, we'll call it as R. And we know that if you look at this triangle, it is a right angle triangle. So we know very clearly r square will be equal to x square plus y square, and then r will be equal to square root of x square plus y square. Now this is the value of r. The value of r is this, and we already defined root of x square plus y square is modulus of z. So this length r represents modulus of the complex number. And if you go from this triangle, if you just analyze, we can see cos theta will be equal to x by r. So that is cos theta, and from here I am going to get x by cross multiplication. So I will get x is equal to r cos theta. Similarly, sin theta, from this triangle sin theta will be y by r. So this will give me y is equal to r sin theta. So y will be equal to r sin theta. Therefore, if you substitute back in z, so z is equal to x plus iy. This is x is r cos theta plus I into y is r sin theta. And suppose you take this r common, I get cos theta plus I sin theta, and r is actually mod z. So therefore this is mod z into cos theta plus I sin theta. So therefore this form is called the polar form of the complex number. So this is called polar form. And here very importantly, this r is nothing but the modulus of the complex number. R is modulus of z. So r is modulus of z, and this theta has a name. It is obvious that this value of theta and this value of theta is always same. It can't have two different values. This value of theta and this value of theta is always same, and theta is called the argument of the complex number. Theta is called argument of z. So this angle has a name. It is called argument of z. In short, it is written as arg of z. Yes, and this is called the polar form of the complex number. That means if I give you a complex number z is equal to x plus iy, you can write this complex number in the form mod z into cos of theta, that is argument of z, cos of argument of z plus I sin argument of z. And this is exactly the polar form of the complex number. Okay, now students, this is just a model. So actually when we go to competitive problems, what we need is we need a quick way to write the modulus and argument, in fact the polar form. Now this point need not be only in first quadrant, the point can be in first, second, third, fourth quadrant, it can also be on the axis. So the various possibilities are there. Therefore, taking into account that we are doing problems in competitive exams, what we will do is we will adopt a very simple procedure to find a polar form of a complex number. In fact, sometimes we want only argument, sometimes we only want modulus, sometimes we want polar form. So all those possibilities are there. Now suppose we give you a complex number z is equal to x plus iy. Now suppose we want to write this in polar form. We are going to adopt a very simple procedure. First, what we will do is the complex number z is equal to x plus iy. We will assume that this complex number is of the form r into cos theta plus I sin theta. And there is no problem with r. R is always root of x square plus y square because it is the modulus of the complex number. So there is no problem in writing r. Now the problem is in writing theta, because what happens is if theta is in the first quadrant, suppose this point x comma y is in the first quadrant, this value of theta will be acute. Now what happens if the point is in some other quadrant? So if the point lies in second quadrant, third quadrant, fourth quadrant, for that, since we are, as I told you, since we know that we are doing problems in competitive exams, we need a very quick method to get theta. So therefore, we are going to follow this very simple procedure. First, what we will do is, when a complex number is given, first we will define an angle alpha. Define an angle alpha given by tan alpha is equal to mod y by x. So just take tan alpha as mod y by x. Okay. So this is just a shortcut method, short way to find theta. So first you define tan alpha equal to mod y by x. Now y and x will be available in the complex number. I will demonstrate it just by taking a question after this. So we'll just we'll adopt this procedure. That's it. So take tan alpha equal to mod y by x. Now the point x comma y. So for this point x comma y lying in various quadrants. So lying in various quadrants, to find theta, you have to just by heart a very small table, and the table is like this. So if I'll divide this table into four parts because there are four quadrants. This is first quadrant, second quadrant, third quadrant, and fourth quadrant. and if the point is in first quadrant, theta will be equal to alpha. So take it like this, and if the point is in fourth quadrant, theta will be equal to minus alpha. Here, okay, because you can see if the point is in the first quadrant, this will be, let us say, if you take this as alpha, if the point is in fourth quadrant, this same angle will be taken minus alpha. There are some reasons for that. We are not going to much depth of all these things. If possible, in one question or something, little I'll demonstrate it. If the point is in second quadrant, take theta is equal to pi minus alpha, and if the point is in third quadrant, theta is equal to negative of this. So theta is equal to alpha minus pi. So if you remember this small procedure, you can write the polar form of the complex number effortlessly, accurately, and within a very short time, maybe within 15 seconds, you can just write the polar form of the complex number. So main is that, students, by heart tan alpha, that is mod y by x, and very importantly, by heart this table. So this will immediately give you the polar form. Now I will take just one example, students. So now I'll take one example. I'll just keep this table intact. Now let us say I want to find the polar form of one complex number. For example, I want to write the polar form of the complex number root 3 plus I. Let us say I'll take one simple example. I just want to write the polar form of root 3 plus I. First, what you have to do is, we'll just assume this. Let root 3 plus I. Now, the meaning of polar form is expressing the complex number in the form r into cos theta plus I sin theta. So this is called polar form. In fact, if you find r and theta here, you are getting the polar form. That's it. Now here it's very clear. The value of x is root 3. X is the real part, and very clearly this is, when you say root 3 plus I, this is I into 1. So imaginary part is 1 here. So y is equal to 1. So using this x and y, immediately we can find r. So as we know, r is equal to root of x square plus y square. R is nothing but the modulus, that is root x square plus y square. So this is root of x is root 3. So this is root 3 square plus y square, that is 1 square. So this will be, here square root and square cancels. So we'll get 3 plus 1, that is 2. So we get r as 2. Now next, according to our procedure, students, first we'll define tan alpha. We will define tan alpha as mod y by x. So we'll take tan alpha equal to mod y by x. This is equal to mod of, now you know y is 1, so I'll just substitute, y value is 1, so y is 1, x value is root 3. And you know mod of 1 by root 3 is same as 1 by root 3. So you'll get tan alpha equal to 1 by root 3. So you can get the value of alpha. So therefore, tan alpha is equal to 1 by root 3, means you know alpha is equal to 30 degree, or I think you have studied trigonometry by now. So tan alpha is 1 by root 3 means alpha is 30, because tan 30 is 1 by root 3. Yes, so first step is finding alpha. Then using this alpha, you can find theta. Now how to find theta? Now you have to see the given point is in which quadrant. Now you know root 3 comma 1 both are positive. So you know that if x coordinate is positive, y coordinate is positive, the point will be in first quadrant. So therefore, here if I go back to this step, in fact if I go back to this step, here you can see x is root 3, y is 1. So therefore, the point x comma y will be nothing but root 3 comma 1. And since both the coordinates are positive, the given point is in the first quadrant. So I will just write it here. The point root 3 comma 1 lies in first quadrant. And if you look at the table here, in the first quadrant, if you want theta, if the point is in the first quadrant, theta will be same as alpha. Therefore, theta will be same as alpha, and this implies theta will be same as pi by 6. And if you substitute this in this step, so if you go back to this step, the polar form is here. Therefore, I can say root 3 plus I is equal to r. R is nothing but 2. See, we got r value here, 2 into cos of theta. The value of theta is pi by 6. So, it is cos pi by 6 plus I sin pi by 6. So, this is this complex number, and this complex number is one and the same. This is in
Sir, one doubt, sir.
yeah.
Sir, the angle must be written in radians, sir, not in degree.
No, you can actually you can take it in degrees or radians, but usually we take it in radians. So that is the convention actually, because radians
Yes, sir.
because radians is the representation of real number system. No problem. You can also, nothing wrong with the writing in degrees. So you can write this as 2 into cos 30 plus I sin 30. So you can also write it like this. Yeah. So
Should we
therefore,
further simplify it, sir?
no, if you simplify, you will get the same thing back. You will get root 3 plus I. This is
Okay, okay.
this is the polar representation of this.
Yes, sir.
Yeah, usually till now we were talking about x plus iy form. Now we are going to talk about this form.
Polar
That's it. Polar
representation.
representation. Yes.
Yes. Oh.
Yes. Okay. Now you can see for the complex number root 3 plus I. So we can say modulus is 2. So here modulus of this complex number is 2, and we can say the argument is pi by 6. So argument is this is called argument. So argument is pi by 6. Yes, or you can also say 30 degree. So 30 degree is the argument. And students, one thing that you have to know is very simple. uh, you can see here the polar form of this complex number is 2 into cos 30 plus I sin 30. And what is the meaning of that? Very simple. If you exactly plot this point root 3 plus I, that means if you plot this point root 3 comma 1, suppose you plot this point root 3 comma 1, you know this point is in first quadrant. Root 3 is approximately 1.7 comma 1. So root 3 comma 1 is, I am just drawing a rough figure, that's it. So we are not drawing anything to scale here. So therefore uh, the point root 3 comma 1 will be somewhere here. And if you join this point to the origin, if you join this point to the origin, the distance from the origin to this point is exactly 2 units. So that will be 2. So this will be 2. So distance from here to here represents the modulus of the complex number. And the meaning of 30 degrees, this line is making 30 degree with x axis. So okay, now in our ordinary x and y coordinate system, these are called Cartesian coordinates. So when I say x comma y, x and y are called Cartesian coordinates. Cartesian, you would have used this word many times. This is called Cartesian form. Similarly, a point can be plotted also in this form, that is at the origin. If you just shift 30 degree at the origin from the x axis, if you make an angle 30, and if you go 2 units like this from origin, you will exactly reach this point. So to reach this point root 3 comma 1, there are two ways. Either you can go along x axis root 3 and y axis 1, will reach this point. you can go root 3 units like this, you can go 1 unit like this, you will get this point root 3 comma 1. Another way is at the origin, if you make an angle 30 degree, and from the origin in that 30 degree direction, if you go 2 units, you will also reach the same point. And these points r and theta, x and y, are called Cartesian coordinates. R and theta are called polar coordinates. R and theta are called polar coordinates. Yes, and therefore comes the name polar form. That is why we have given the name as polar form. Okay, so now students, I will take up another one or two questions and quickly find the polar form of some numbers. So now let me just uh, uh, find out the polar form of this number, root 3 minus 3i. So let us try to find the polar form of this. Okay, so let me do this systematically, step by step. First, we will take like this. Let root 3 minus 3i. We will assume this polar form to be r into cos theta plus I sin theta. So we will just assume the polar form to be like this. And here, when you look at this complex number, you can say that x is equal to root 3, and if you look at y, y is equal to minus 3. So sign is very important because you have to decide the quadrant. So that is very important. So x is equal to root 3, y is equal to minus root 3. Now to find r is very easy. As you know, r is given by root of x square plus y square, and that is root of x is root 3. So it will be root 3 square plus y. Y is minus 3. So it is minus 3 square. So this is, here square root and square cancels. You will get 3 plus minus 3 square is 9. So you will get root 12, and root 12 is 2 root 3. So this is the modulus of the complex number. And to find theta, you have to do a double procedure. First you have to define tan alpha. So first we will write tan alpha. So to find theta, first we will find tan alpha. So tan alpha will define it to be mod of y by x. So this is always true for any complex number. So just define tan alpha equal to mod y by x. This is mod of y is minus 3 divided by x is root 3. And you know, this, whenever mod is there, minus sign you can ignore. This is nothing but 3 by root 3. So check this step, students. Mod of minus is there, just forget it, 3 by root 3. And you know, 3 by root 3 is root 3, because 3 can be written as root 3 into root 3 divided by root 3. So root 3 is going to get cancelled, and therefore we will get this as root 3. So we get tan alpha equal to root 3. So therefore tan alpha is equal to root 3. Yes, I think most of you find comfortable with degrees. So I'll just write, if tan alpha is root 3, we know alpha is 60 degree. We get alpha equal to 60. And very important is, where is this point? The point root 3 comma minus 3. Okay, so this point, you can see this point root 3 comma minus 3. This point lies in fourth quadrant. You know, this point lies in fourth quadrant. Plus minus, you know, plus and minus is fourth quadrant. Okay, so if, okay, now we can see that if it is fourth quadrant, the value of theta is negative of alpha. Therefore theta will be equal to minus alpha. So theta will be equal to minus of 60 degree, or theta is equal to minus pi by 3. Yes, so students, this is theta here. Okay, therefore uh, root 3 minus 3i is nothing but, so if you go to the first step here, r is 2 root 3 into cos of theta. Theta is minus pi by 3 plus I sin minus pi by 3. So this is the polar form of the complex number root 3 minus 3i. And if you
Sir, cos minus theta is cos theta, no, sir?
yes, that simplification you can do. Cos of minus pi by 3 you can, okay, if you want that, yeah, when I go to specific problems I'll do that. Here I just want, yes, cos of minus theta you can write it as cos theta, and sine of minus theta you can write minus sine theta. So if you know that, you can do that. Yes. So therefore this is the polar form. And if you geometrically see the figure, if you geometrically see the figure, just to have a small idea about all these things. Okay, now you know root 3 comma minus 3, this point is in the fourth quadrant. Root 3 comma minus 3 is somewhere here. It is in the fourth quadrant, root 3 comma minus 3. And if you join this line to the origin, if you join this line to the origin, we take this angle to be negative. Okay, so clockwise direction. This angle is clockwise direction. So we take this angle to be negative, and therefore this angle is exactly minus 60 degree. So this angle is minus 60 degree. This angle is minus 60 degree, and the length of this line, the length of this line is the modulus of the complex number, which is 2 root 3. This is what exactly the polar form represents. Yes, and just for practice students, quickly I'll do the polar form of another one complex number. So now let us try to express the complex number minus 1 plus I in polar form. So let us do the standard procedure answer. So first we'll assume the polar form. So I can say something like this: let minus 1 plus I be equal to r into cos theta plus I sin theta. So first we'll assume it like this. Yeah, then quickly I'll write the value of x and y. Here the value of x is minus 1 and the value of y is 1. This is I into 1. So I into 1. So value of y is 1. So we can find r here. R is nothing but root of x square plus y square, that is root of minus 1 square plus 1 square. So we get this as root 2. So check r. Then immediately write to find theta, as we said, we'll go for a two-step procedure. First we'll find tan alpha, which is mod y by x, which is equal to mod of y is 1, x is minus 1, and this will be 1 itself, because minus sign goes under the modulus. 1 by 1 is 1, and we know alpha is equal to 45 degree. If tan alpha is 1, alpha will be 45 or it will be pi by 4. Yes. Now very important is to find theta. To find theta, you have to identify in which quadrant is the point. So the point x comma y. So the point minus 1 comma 1 lies in second quadrant. Correct, no? So minus 1 comma 1. So the point will be,
Sir, can we take pi as validity degree, sir?
yeah, if you take pi as 180, you will get same thing, no? 45, no?
No,
Pi
no,
into
no, not for this, sir. For further step, I'm saying. As it's in second quadrant, it's pi minus
yeah. Okay.
theta. There
Yeah,
can I take it as validity degree?
you can take it. Nothing wrong in that. So theta, okay, if it is in second quadrant, theta will be pi minus alpha. Second quadrant, the rule is theta is pi minus alpha. So therefore, this is pi minus pi by 4, which is equal to 3 pi by 4. Yes, and obviously you know students, if the point is in second quadrant, the angle will be obtuse. See, the point minus 1 will be minus 1 1 will be somewhere here, and this angle will be 135. 3 pi by 4 is actually 135 degree. 180 minus 45, so this is 135. Yes, so therefore this is 3 pi by 4. Therefore the polar form is, if you go to the first step, you will get minus 1 plus I is equal to r. R is equal to root 2 into cos of theta is 3 pi by 4 plus I sin 3 pi by 4. Yes, so this is the polar form. Yes, let me remind you again, root 2 is called the modulus, and 3 pi by 4, this 3 pi by 4, this angle is called the argument of the complex number. So yes, yeah. So yes students, this is how we remember the this is the method to write the polar form. And it is better you yes, I think in the last class I was talking about that. So now there is only one complex number which does not have polar form, the number 0. 0 does not have polar form because 0, if you write 0 as 0 plus I into 0, you can see that first thing is the modulus of the complex number will be 0. That is the first point. Yes, that is one problem. Next is the angle alpha will not, alpha and theta will not exist. You know tan alpha is equal to mod y by x. Just now we saw that, and therefore this y and x both will be 0. So 0 by 0 does not have a definite answer. So therefore it is not possible for us to find angle alpha, and hence it is not possible to find theta. So we cannot find the argument of this. So therefore complex number 0 does not have polar form. Any other complex number you can find the polar form by this method. Yes, the polar form does not exist at all for 0. And it is better to remember the polar form of some very important numbers. So the polar form of some important complex numbers, I is actually cos pi by 2 plus I sin pi by 2. This is the polar form of I. And after this, just now we saw, when a complex number x plus iy is written in polar form, it will look like this: r into cos theta plus I sin theta. Now sometimes to write this in short, every time to write cos theta plus I sin theta, it is little tedious. So we write this as a short form. Cos theta plus I sin theta is written as cis theta or cis theta we call. C for cos, I for imaginary term, I for I, S for sin, and theta for argument. So cos theta plus I sin theta can be written as cis theta. So the polar form of I is cos pi by 2 plus I sin pi by 2. If it is better you remember this, and it is cis pi by 2. You can write in short, you can call it as cis pi by 2. Similarly, the polar form of minus I is cos of minus pi by 2 plus I sin minus pi by 2. And in short, you can write it as cis of minus pi by 2. This is the polar form of minus I. Then polar form of 1. 1 is cos 0 plus I sin 0. Yes, you can actually verify there only. Cos 0 is 1, sin 0 is 0, so you will get 1. So it is cos 0 plus I sin 0, which can be written as cis 0. And polar form of minus 1 is cos pi plus I sin pi. This is the polar form which is written as cis pi. Yes. So I think if you have finished allied angles by now, you will be knowing this. Cos pi means cos 180 plus I into sin 180. And if you do allied angle calculation, which we are not interested here,
minus 1
yes, correct. Cos 180 is minus 1, and you know when cos
plus 1.
become, yes, when cos becomes 1 or minus 1, sin is always 0. When cos is maximum or minimum, sin is always 0. So cos 180 is minus 1, sin 180 is 0. So you will get this as minus 1. Yes. Okay. So minus 1 is cis pi. So therefore, students, it is better you remember this polar forms. And one or two points what I want to tell you is some properties of argument. So when you write a complex number as z is equal to r into cos theta plus I sin theta. So as I said, theta is called the argument. In general, theta is called as argument of z. Theta is called argument of this the complex number. Theta is called argument of z. So you know that. Now this theta has some very important special properties. Okay, that is, if you want to find argument of z1 into z2, argument of product of two complex numbers is sum of their arguments. It is argument of z1 plus argument of z2. Now this will be very helpful in some JE questions. It's very important property. So argument of z1 z2 will be is not argument of z1 into argument of z2. Argument becomes addition. So argument of z1 z2 is argument of z1 plus argument of z2. Similarly, argument of z1 by z2. So if you want argument of division of two complex numbers, it is argument of z1 minus argument of z2. So if you know the properties of logarithm, I don't know whether you have studied them. Argument acts like log. Log of m into n is log m plus log n. So you might have used it in some physics or some other topics. Later I will also take up small part of logarithm later, but that okay, but you have used all these things. Then argument of z bar. Anybody knows this? Any guesses? What is argument of z bar? Argument of z bar is minus argument of z. So this is very important. And argument of z power n is equal to n times argument of z. Yes, these are four very important properties of argument. So therefore, it is better to know this, students. Okay. Now sometimes suddenly if we write these properties like this, we don't get feel of the question. So it okay, I think it will be a 5-minute time, but still I just want to sacrifice that time to show one example how, okay, we can prove these properties that is there, but since again we are only dealing with JE topics, we are not going to do the proof of this because it will kill a lot of our time. So what we are going to do is, I'll just show you a small example. Just now we took the complex number root 3 plus I. Just now we did root 3 plus I, and we got this answer polar form as 2 into cos 30 plus I sin 30. So we got this, and in from here we can say, okay, we'll call this complex number as z1 because I'll be taking another one. Now for z1 you can see this angle is 30, so immediately I can say argument of z1 is equal to 30 degree. This was the first question which I did just now. Similarly, the second question which I did was root 3 minus 3i. This was the second question which I did, and we got this polar form as root 12 into cos of minus 60 plus I sine minus 60. We got it like this, and from here we can say argument of this complex number z2 is this angle, which is minus 60. Argument of z2 is minus 60. Now what I am going to do is I will see this z1 into z2. Let me just quickly multiply these two complex numbers. If you do z1 into z2, you will get root 3 plus I into root 3 minus 3I. If you just multiply this z1 into z2, you will get this into this, and if you simplify, root 3 into root 3 is 3, then root 3 into minus 3I is minus 3 root 3I, then I into root 3 is root 3I, and if you multiply this with this, uh, I into I becomes I square, which is minus 1. With this minus it will become plus, so I think this will become plus 3. Yes, and this complex number will become 6 minus root 3I plus root 3I is minus 2 root 3I. So you can check this, students. Minus 3 root 3 plus root 3 is minus 2 root 3. Now quickly I will just find the uh, argument of this complex number. So if I want to find the argument, first here you can see here x is equal to 6 and y is equal to minus 2 root 3. And if I find tan alpha, so tan alpha is equal to mod y by x, and this is equal to mod of y is minus 2 root 3 divided by x is 6, and here 2 will cancel 3 times, and under the modulus minus will become plus, so you will get 1 by root 3. Correct, no? Root 3 by 3 is 1 by root 3. So from here we will get alpha is equal to 30 degree, because tan 30 is 1 by root 3. Now the point 6 comma minus 2 root 3. The point 6 comma minus 2 root 3 lies in fourth quadrant. Therefore, theta will be equal to minus of alpha, that is minus of 30. So you get this. So students, argument of the complex number z1 z2 is minus 30, because this I got by multiplying z1 into z2. So now I can say argument of z1 into z2 is equal to minus 30. Now we will add argument. See, here we have argument of z1 and we have argument of z2. Let us add this. So argument of z1 plus argument of z2 is equal to 30 minus 60, which is same as minus 30. So you can see argument of z1 into z2 is minus 30. Argument of z1 plus argument of z2 is also minus 30. So from here we can conclude argument of z1 z2 is equal to argument of z1 plus argument of z2. So when you multiply two complex numbers, what will happen is their arguments or the angles will not multiply, they will get added. So therefore that is the rule about. So similarly division, etc., those properties what I wrote are something similar to this. Yeah. So yes, students, after having done this much, last one small point which I want to tell is what is meant by exponential form. That's it, but we are not going to use it much today. So what is meant by exponential form? Yes. Now usually a complex number has three forms. One is the normal algebraic form. This is called algebraic form. This is algebraic form. And just now we saw, except complex number 0, any other complex number can be converted to this form, and this is called polar form. In fact, both are same, but only they look different, but they represent the same. And there is another form called exponential form. There was a mathematician with the name Euler, or some call it as Euler. There was a mathematician by the name Euler. He later showed that cos theta plus I sin theta can also be written as e to the power I theta. So this is what he showed later. Yes, that means I'll just talk about E now. So therefore, this complex number can also be written as R. We'll write it as it is. That will not change. Instead of writing cos theta plus I sin theta, we can write this as e to the power I theta. And this form is called the exponential form. This is called exponential form. Yes. Now there is no special method to find the exponential form, because even in exponential form you have to just find r and theta. That's it. So just now we have had this complex number root 3 plus I. Root 3 plus I is the algebraic form. 2 cis pi by 6 is the polar form, and if you write 2 into e power, suppose you put theta value here, that is I is there. If you put theta equal to pi by 6, this is called the exponential form. So root 3 plus I algebraic, 2 cis pi by 6 polar, 2 e power I pi by 6 is called exponential form. That's it. So sometimes exponential form is very helpful, sometimes polar form is helpful, sometimes algebraic form is helpful. It depends from problem to problem. So that decision we have to take. So today we will be picking up some questions. So this is actually, this is it, students. And what is this E? Yes, so we have to study this later, especially it comes very regularly in next 12th standard calculus. It comes regularly. And just talking about E, I'll not spend much time speaking about E. Now all of you know that there is a very famous irrational number called pi. So its value is approximately 3.1416, and it is a non-terminating, non-recurring decimal. It is an irrational number. Pi is an irrational number. Similarly, there is a constant in calculus, in maths. In calculus, there is a constant called E, and this E is called Napier's constant. Yes, it was invented by a mathematician named as Napier, so it is named after him. It is called Napier's constant. Yes, and this E, like pi, how it has a very good significance in maths, this E also has a lot of significance. In fact, most of this, only if you go to research, like in higher studies, if you go to research, will go to the depth of this. Otherwise, this E is called Napier's constant, and the value of E, just like pi, this E is also a irrational number, and its value is approximately 2.7184, etc. So this is a non-terminating, non-recurring decimal. So this is the value of E, and this E is actually used in exponential form. So that is actually E here. Okay, so I hope
So are we
students.
substituting the value of this, sir, or we're just writing it as is?
No, we are not substituting the value of E actually. We are keeping E intact. We are keeping E as E because we can't substitute, because this value of E is a non-terminating, non-recurring decimal. But I think almost at the end point of our classes, not today, at the end point of this chapter, I will do some 3 or 4 problems on E. 3 or 4 problems I'll do, because nowadays they are not asking this concept. But suppose if for you, if in one paper if it is asked, so only for the sake of safety I'm doing this actually. But polar form is very important actually.
Yes,
So
sir.
yeah, so okay students, if that is the case, now we can now go to some questions now. Yes, okay. uh, 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 yes. So let us go to question number 13. So for time being, I'll just keep that question number 12 pending, because for question number 12, I have to explain what is called as De Moivre's theorem. So today we have done a lot of explanation. So therefore, I still don't want to do much explanation. So that will be very hard for you. We can do it in the next class. So now I will go to question number 13, students. So we can go to 13th question. So I will just briefly write down what is the question. So question number 13 is something like this. Now this question was asked in JE 19. It is a very nice question to explain the concept here. So they are saying z naught be a root of x square plus x plus 1 equal to 0. So they are saying z naught is a root of this quadratic equation, and they are saying if z is equal to 3 plus 6i into z naught power 81 minus 3i into z naught power 93, this is 93, then what is argument of z? Yes. So we have to find the z means this. So we have to find the argument of this complex number. Okay. Now students, this is a very important question which relates to omega. So last class we have seen x square plus x plus 1 equal to 0. We know the property of omega. 1 plus omega square is always equal to 0. And if they say root, if they talk about root of x square plus x plus 1 equal to 0, you can take the root of this as omega, because x is equal to omega satisfies this, because if you put x omega, 1 plus omega square equal to 0. Nevertheless, when I was doing the problems in the last class, I told you if they talk, if anywhere the topic comes like this, root of x square plus x plus 1 equal to 0. Whenever this comes, immediately you can take x is equal to omega or omega square. If both roots are needed, you can take both. Otherwise, if they say a root, see they have said a root. So when they say a root, you can take either this root or this root. Similarly, if the topic is root of x square minus x plus 1 equal to 0. If it is like this, then you can take x is equal to minus omega or minus omega square. So we already spoken about this, students. Okay. Now if they say z naught is a root of this, means root of this is omega, therefore automatically z naught should be omega. So I'll start my explanation here. Clearly z naught should be equal to omega, because x square plus x plus 1 equal to 0, the root of this is always omega. Yes. So now in the place of z naught here, let me put omega. So therefore I will get, so we are going to get z is equal to 3 plus 6i into, instead of z naught I'll put omega. So I'll get omega power 81 minus 3i, again z naught is omega power 93. Yes, this is z is equal to 3 plus 6i into, we have seen omega power multiple of 3 is always 1. So omega power 81 is a multiple of 3. So omega power 81 will be 1 minus 3i into, I think again you will agree with me, 93 is a multiple of 3. So omega power 93 will also be 1. So you will get z is equal to 3. Now this is 6i minus 3i, which will be equal to 3i. So you will get z is equal to 3i. And now the question is very simple. They are asking argument of z. And to find the argument of this complex number, we have a method. Here x is equal, there is no need to find the modulus, directly the argument. Here x is equal to 3 and y is equal to 3. And to find the argument, first find tan alpha. So tan alpha is equal to mod y by x, that is mod of 3 by 3, which is equal to 1. And if tan alpha is 1,
45 degrees, sir.
yeah, 45 degree. So if tan alpha is equal to 1, alpha will be equal to 45 degree. Correct. Now the point 3 comma 3. Now that's very important. The point x comma y. The point 3 comma 3 lies in first quadrant. And we know in first quadrant from that table theta is equal to alpha, and alpha is 45. So therefore theta is equal to 45 degree. So they had asked what is the argument. The answer is 45 degree. And if we look at the options given are pi by 4. So first option is pi by 4. So the first option itself is the answer. So option A is the answer. Pi by 4, pi by 6, pi by 3, 0. So therefore it's very clear. Pi by 4,
5/4.
4. Yeah, pi by 4. Option A is the answer. Yes. Then students, let me go to the next question. Question number 14. Yeah, again question number 14 is actually to be done by using De Moivre's theorem, but I will use another method just for you to know that. Uh, okay, so let me go to question number 14 now. Yes, 14 is like this. They have given z is equal to, they have given a complex number z, and they have given it like this. It is root 3 by 2 plus I by 2 power 5 plus root 3 by 2 minus I by 2 power 5. Then they have said options. Option A, imaginary part of z is 0. This is the first option. That means you have to simplify this full complex number and tell them which option is correct. Option 1, imaginary part of z is 0. This is first option. Option B, real part of z is greater than 0. Imaginary part of z less than 0. This is the second option. Third option, real part of z is less than 0. Imaginary part of z greater than 0. Yeah, this is just opposite to option B. And option D, real part of z is equal to minus 3. So these are the options given to us. Yeah,
Sir,
yeah.
it's given option B as imaginary part greater than 0. Should we change that?
Oh, yeah, yeah, yeah. Sorry, sorry. This is given like this, no? Yes, correct. Yeah, yeah,
Okay,
you
okay.
are right. You are right. Yes. Yeah, it's given like that. Okay. So now this problem actually can be done by what is called De Moivre's theorem. For that, the thing is first you have to write the polar form and all. I'll do it in the next class in some other questions. So we have to do that. But why I am interested in this question is there are some tricks that can be got from this. Now you carefully look at this number, students, root 3 by 2 plus I by 2. Now we know what is the value of omega. Now the value of omega is now working. These kind of tricks in some questions will really reduce a lot of work. Okay, this maybe for example, for this question, doing what I am doing now may reduce the work up to 30%, but there are some questions where 60 to 70% of the work get reduced. Now first I'll write what is omega. Now we know what is omega, we have learnt it in the last class. Omega is minus half plus I root 3 by 2. This is a very important value. Now here what I will do here is, you can see this minus 1 here. See, you can see this minus 1 here. This minus 1 I will write it as I square, because you know I square is minus 1. So this minus 1 I will write I square. So minus half can also be written as I square by 2, so which is one and the same, plus I into root 3 by 2. So you can write it like this. And from here, students, if I take I common, suppose I take I common from here, from this, I will get this term. I'll write this term first, because when I take I common, this will be without I now. So this will be root 3 by 2 plus, and since I have taken I common here, this will be I by 2. So check this, and you are exactly getting the first term here. See, root 3 by 2 plus I by 2. That means from here I can say, now my left side is omega. Omega is equal to I into root 3 by 2 plus I by 2. Yes, but I want root 3 by 2 plus I by 2. So from here I can say root 3 by 2 plus I by 2 is omega by I. And I am just making it long. This just needs around 5 seconds to do this simplification actually. By practice it will come. So see this, I want root 3 by 2 plus I by 2. See, root 3 by 2 plus I by 2 is nothing but omega by I. That means we'll get omega by I. I'll just cross multiply this. So omega by I is equal to root 3 by 2 plus I by 2. And you know this, students, I have told it in my first class of synopsis, 1 by I is minus I. So therefore, this here, this part is there, no? 1 by I, that will be minus I. That means from here I can conclude root 3 by 2 plus I by 2. So from here I can conclude root 3 by 2 plus I by 2 is equal to 1 by I, that is minus I into omega. So let me take it as 1. Yes. So this part is got. Now similarly, students, so we'll get another practice here. We know what is omega square. So omega square is the conjugate of this actually. So omega square is minus half minus I root 3 by 2. Yeah. So check this, students. So from here I can write omega square is equal to same way, if I write this minus 1 as I square, check this step, students. This I am talking about this minus 1, same like the last one. Minus 1 I have written as I square by 2, because I square is minus 1, 2 is as it is, and other things I have not touched. I have written it as it is. So from here I can write omega square is equal to, okay, so can you get this term? So if you take minus I common from this term and this term, if you take minus I common, I'll write this term first, because see here it is plus root 3 by 2. So I'll take this minus I common. So I will get root 3 by 2. This term I'll write first, and since I have taken minus common, but this is plus here, it will become minus I by 2. So just check this, students. See, I'll just make a verification. Minus into minus is plus, I into I is I square and 2. So it will become like this, and I am actually getting this term now, root 3 by 2 minus I by 2. Now this minus I, if I cross multiply, I will get omega square by minus I is equal to root 3 by 2 minus I by 2. And just now we saw 1 by I. 1 by I is minus I actually, and there is another minus sign here. So 1 by I is minus I, with this minus it will become plus. So you will get I is equal to root 3 by 2 minus I by 2, sorry, I omega square. So check this, students. Otherwise also remember this, 1 by I is minus I. then 1 by minus I should be obviously I. So note that. So here 1 by minus I directly can write it as I in that case. Yes. So now we will come back to this problem, students. So what I will do is, in the place of root 3, okay, so therefore, so I will continue here, z is equal to, now root 3 by 2 plus I by 2, it is here, okay, we will call this as 2. Root 3 by 2 plus I by 2 is minus I omega. So therefore, this I can replace by minus I omega whole power 5 plus root 3 by 2 minus I by 2. It's here, equation number 2. Root 3 by 2 minus I by 2 is I omega square. So this is I omega square power 5. So now we will just simplify this. You know, minus power 5 is minus, and I power 5 is actually I, no, because I power 5 is equal to I power 4 into I power 4 is 1 into I. So, I will get I. So, I power 5 is I. Now, what is omega power 5? Now, omega power 5 is actually omega square. Omega power 5 can be written as omega power 3 into omega square. Omega power multiple of 3 is 1 into omega square. So, I will get omega square plus I power 5. I power 5 is I actually. Okay, we have done it here. Same, I power 5 is I. So, this is I into, this is omega power 10. Now, omega power 10 is omega, because omega power 10 can be written as omega power 9 into omega. This is 1 into omega. So, therefore, it can be written as omega. Yes. So, now students, z is equal to, now I will finally do the final round of simplification, minus I. Let me write it as it is. Now, I will substitute what is omega square now. Now, we know omega square is minus half plus I root 3 by 2 plus I into omega is minus, omega square is minus half minus I root 3 by 2, omega is minus half plus I root 3 by 2. Yeah. So, now we have to get our answer. So, we get z is equal to, now when you multiply inside, minus into minus becomes plus. So, this will become I by 2. Then when you multiply this with this, minus into minus becomes plus, but I into I becomes I square. So, again it will become minus root 3 by 2. Then I into minus half, this will be minus I by 2, and I into I into I is I square, that is minus 1 root 3 by 2. So, this term is going to cancel with this term, and therefore, we will get z is equal to minus root 3 by 2 minus root 3 by 2 is nothing but minus 2 root 3 by 2, which is same as minus root 3. Now, which is the correct answer? You can see the options.
Option is
Yeah, correct. Option A is the answer. You can see this minus root 3 can be written as minus root 3 plus I into 0, and you can see the imaginary part is 0. So, therefore, option A is the answer. No other options will satisfy this. Here option D, real part of z is minus 3 they have given. Actually, here it is minus root 3. So, this is gone. Yeah, real part of z less than 0 is correct, but imaginary part of z is greater than 0. That is wrong. It is 0. Therefore, similarly, option C and B are out. So, it is very clear option A is the answer. Now, usually students, when root 3 by 2 and I by 2 are coming in a question, usually omega will work. So, you can do it in this way. So, right now you may feel that this is going longer. It is actually not going longer. You can quickly do these steps actually. So, it's possible possible. So I just wanted to demonstrate that these kind of calculations can be done. Yeah, okay. Now let us go to question number 15, students. Uh, question number 15. Yes, this question is little on the higher JE level actually. Question number 15. They are saying Z and omega are non-zero complex numbers. So Z and omega are non-zero complex numbers. Now this omega does not have to do anything with our imaginary cube root of unity, that is minus half plus I root 3 by 2. It is not that omega. They have clearly said that Z and omega are some complex numbers. Yes, it is not a standard omega, such that mod of Z into omega equal to 1. So they have given like this, mod of Z into omega equal to 1, and also they have given argument of Z minus argument of omega equal to pi by 2. So they have given like this. Then the question is, what is Z bar into omega? Yes. So the options are, I'll just write the options here, A1, B minus 1, Ci, D minus I. So these are the options. Yes. Okay. So how can this question be tackled? Yeah.
So using the properties which you gave before, sir, like argument
Ah,
of z1 to z2
yeah.
is
Yes.
equal to argument of z1 plus argument of z2.
Yes. We have to use something like that. Yes. But I don't think so. All those properties will come. But okay, let us see. No problem. Yeah. So now what I will do is, students, you have to find what is Z bar into omega. So that's very important. So the question lies here, Z bar into omega. Now what I will do is, first from here, so they have given me argument of Z. So they have given argument of Z minus argument of omega is equal to pi by 2. Now from here what I will do is, I will write it like this. I'll just move this minus sign to this side. From this I can say argument of Z is equal to, argument of Z is equal to pi by 2 plus this minus, when it comes like this side it will become plus argument of omega. So I have done nothing much, I have just moved this term to this side. So argument of Z is equal to pi by 2 plus argument of omega. Now students, here you can see argument of Z depends on argument of omega. So we will assume one value for argument of omega randomly. So we will see, we will set like this. Let argument of omega be equal to, now what is the meaning of argument? Argument of a complex number is the angle. Always remember that, correct? No? Argument of complex number, see, when you write a complex number x plus iy in the form r into cos theta plus I sin theta. When I say the word argument looks something big, but argument is nothing but this angle theta. This is called argument. Yes. So let me call argument of omega, let me assume it to be some theta, then immediately I can say, therefore let argument of omega, let this value be equal to theta. So whenever I say argument of a complex number, it is the angle there. So let argument of omega equal to theta, then what will happen is argument of z, no, argument of z will be pi by 2 plus theta. So I can say argument of z is pi by 2 plus theta. Yes. Now students, here comes the trick. If this trick is understood, the whole problem is solved. Now come back to this step. what is the meaning of argument of omega equal to theta? Now, why I wrote argument of omega is theta is just to manage this equation. That's it. Now, what is the meaning of argument of omega equal to theta? Now, when I say argument of omega equal to theta, that means this is very important. When I write this complex number, this is complex number, this omega is a complex number. Omega can be written in the form r into cos theta plus I sin theta. Very important. When I say argument of omega equal to theta, see, for example, that time we got like this. We got one complex number, root 3 plus I is equal to 2 into cos pi by 6 plus I sin pi by 6. If you remember my first question today under polar form. So when I say, okay, this is z, let us say z. When I say argument of root 3 plus I is pi by 6, what is the meaning of that? See, the meaning of this argument of root 3 plus I is equal to pi by 6. What is the meaning of that? When I say argument of root 3 plus I is pi by 6 means there will be a polar form of that, and with cos and sine, what angle comes will be pi by 6. That is the meaning of argument. So when I say argument of omega is theta, that means omega will have some polar form. That's very important. So omega will have some polar form, r into cos theta plus I sin theta. This angle here will be theta. That is the meaning of argument. Yes. Okay. And actually this r can be written as, what is r? It is its modulus. So therefore r actually can be written as mod omega. Yeah. Now we'll go to this, students. What is the meaning of argument of z is equal to pi by 2 plus theta? What is the meaning of that? So argument of z is equal to pi by 2 plus theta. See, I have got that. Argument of z is pi by 2 plus theta. The meaning of this means this complex number z will have a polar form. That means z is equal to, argument of z is pi by 2 plus theta means z is equal to mod z. Here if it is z, here it will be mod z into, first term will be cos, into pi by 2 plus theta will be the angle there. So cos pi by 2 plus theta plus I sin pi by 2 plus theta. I hope this point is clear. When I say argument of z is pi by 2 plus theta means that complex number will be z. It will have a polar form, and in that polar form this term will be modulus of that, because this is r, modulus, and the angle within will be equal to the argument, that is pi by 2 plus theta. And I suppose, students, you have finished uh, trigonometry, and if you have finished trigonometry in allied angles, you have studied this. So whenever 90 comes here, the trigonometric function will change. So cos 90 plus theta is sin theta, and you know 90 plus, 90 plus is second quadrant. So this is second quadrant. Second quadrant cos is negative. In fact, if you have finished allied angles, you will be knowing this. Cos 90 plus theta is minus sin theta plus I into. Similarly, sin 90 plus theta will be equal to cos theta. Correct, no? Yes. Okay. So therefore, can anybody tell me what will, now I want, okay, so I got, see, I want z bar into omega, and I have got omega already here. I have got omega already here. Yes. But if they had asked z into omega, I would have multiplied this, but they have asked us z bar into omega. Now anybody can tell me, if z is this, what would be z bar? Can anybody tell me? If z is mod z into minus sin theta plus I sin
Z
theta,
bar into sin theta minus I cos theta.
what is that? Z bar is equal to mod z into, this will become minus, that's it, conjugate, no? Conjugate is always got by changing the sign of the imaginary part. So this will not change. So if z is mod z into minus sin theta plus I cos theta, z bar will be mod z or mod z bar, because mod z or mod z bar is one and the same. It will be only this sign will change. So this is minus sin theta minus I cos theta. Yes, and we are almost at the end, students. Now what I am going to do is, since there was z bar into omega, let me multiply this with this. So therefore if I multiply, therefore this question is based on understanding of polar form. You can see that, yeah. So it can be a little tough questions, tough question if you don't understand the topic. So therefore if you multiply z bar into omega, let me name it if you want, 1 and 2. So let me just multiply equation 1 with equation 2. So if you multiply, you will get z bar into omega. In fact, that is the question now, is equal to, this will be mod z into mod omega into minus sin theta minus I cos theta into cos theta plus I sin theta. So you get it like this. So when simplified, now we have to get one of the options. So now let us try now. Yes, and I think students you will understand this. This is 1. You can see mod z into omega is 1. That means modulus can be broken. Mod of z1 into z2 is mod of z1 into mod of z2 equal to 1, and that's what we have got. So mod z into mod omega, this will be 1 itself because of this. So this is the visualization of that. So therefore we will get z bar into omega will be equal to, now if you multiply this term by term, this is minus sin theta into cos theta, that is minus sin theta cos theta. Then if you multiply this with this, minus sin theta into I sin theta, it will be minus I sin square theta. Then if you multiply this with this, this is minus I cos theta into cos theta minus I cos square theta. And if you multiply this with the last term, minus I into I minus I square is plus 1, because I square is minus 1. So minus I into I is minus I square cos theta sin theta. So you can see that the first term cancels with the last term. So you will get z bar into omega is equal to, if you take minus I common from here,
Minus I, sir.
yes, minus I is the answer, correct. If you take minus I common, you will get sin square theta plus cos square theta, and since this is 1 now, since this is 1, so the answer comes minus I. So option D. So fourth option is the answer. Yeah. So we can just start with the 16 sum, students. I will give you some inputs, then you can try it by your own. I will maybe continue that in the next class. So 16 question. So z comma omega be complex numbers. So z and omega are complex numbers. Now this is very much connected to the last question. So z comma omega be complex numbers such that z bar plus I into omega bar is equal to 0, and they have given argument of z into omega equal to pi. The question is, what is argument of omega? This is the question. What is argument of omega? Yeah. One thing that immediately strikes here is, students, this was the property that I gave you. Argument of z1 into z2 will be argument of z1 plus argument of z2. Yes, I also demonstrated by using one problem also that is that result. So from here, argument of z into omega, I can write it as argument of z plus argument of omega equal to pi. Yes. So we can stop at this stage, and you have to get something more from here. So here the best thing is, I can take this to the other side. From here I can say z bar is equal to minus I omega bar. If you take this to this side, we will get it like this. And now I think students will be knowing this. Z bar is nothing but z itself. Therefore, I will take the conjugate on both sides. Therefore, z bar bar is equal to minus I omega bar whole bar. So, I will just apply conjugate on both sides. That time z bar, this will become z equal to. Now, this simplification is very important, students. Z1 into Z2 bar is actually Z1 bar into Z2 bar. So therefore, if you simplify this, this is minus I bar into omega bar whole bar. Check the students, minus omega bar into omega bar. I have used that under multiplication, conjugate will get broken. Yeah. So therefore, from here I can say z is equal to, now omega bar, the second term becomes omega. So you know that same property. Yeah. Now anybody can tell me what is minus I bar?
Plus I.
Plus I. Yes, very good. Okay. Minus I is 0 minus I. Actually, the meaning of minus I is 0 minus I. If you say minus I bar, that means you are writing the conjugate of this. So minus I is 0 minus I. Minus I bar means it will be 0 plus I, conjugate. Conjugate of a, if this complex number is x plus x minus iy, its conjugate will be x plus iy. So it will be I. Yes. So this will be I. Okay. Now I will just give you the input here, students. Now what you do is, you apply argument on both sides. Therefore, from here I can say argument of z is equal to argument of I omega. Just apply argument on both sides. This will give you argument of z is equal to, now again the property, argument of z1 into z2 is argument of z1 plus argument of z2. So this will become argument of I plus argument of omega, and this implies argument of z is equal to, anybody can tell me what is argument of I? Anybody? Today we saw the polar form of I. I is cos pi by 2 plus I sin pi by 2. If you remember, yeah, argument of I is pi by 2, because I is cos pi by 2 plus I sin pi by 2. This is the argument. The angle part of the complex number will be always argument. So always remember this also, students, argument of I is pi by 2. This is pi by 2 plus argument of omega. If you have got this, it is as good as getting the answer. Why is that? Because we will get two simultaneous equations here. In fact, if you bring this to this side, you will get argument of z minus argument of omega is equal to pi by 2. And in your high school students, you have studied simultaneous equations. Suppose you get something like x plus y equal to 5, x minus y is equal to 1, you solve this. So similarly, you are getting argument of z plus argument of omega is pi. Here you get argument of z minus argument of omega equal to pi by 2. So argument of z minus argument of omega equal to pi by 2. So you have to solve this, and the question is to find, just see the question one, students. The question is to find argument of omega. That means don't cancel this. Yeah, you can cancel, but if you cancel, you will lose that, and then you have to again solve. You just change the sign. So just change the sign of this. Minus, plus becomes minus, minus becomes plus, plus becomes minus. So that time argument of z and minus argument of z cancels. So this will be argument of omega plus argument of omega. So it will be 2 times argument of omega will be equal to, this is pi is 180, pi by 2 is 90. So 180 minus 90, if you want, I'll write it in degrees. 180 minus 90 is 90. So you'll get argument of omega is equal to 45 degree. In fact, I solved this problem fully. So therefore 45 degree pi by 4 is the answer. And if you see the options are pi by 4, 5 pi by 4, 3 pi by 4, pi by 2. So option A, pi by 4 is the answer. Yeah. So okay, students, our time is done for today. So we'll come up with the next concept, De Moivre's theorem, in the next class. Okay. So thank you and goodbye all of you.
Thank you so much.